So we are going to solve this question. Calculate the total inductance in Henry of the circuit shown below. So this is a circuit, and here you can see three inductors are given: 50 Henry, 20 Henry and 60 Henry, and these are the mutual inductance linking the inductance: 10 Henry, 12 Henry and 20 Henry. So you have to find the total inductance of this circuit.
So total inductance, that is when inductors are connected in parallel, the total inductance is given by 1 by L equivalent is equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus etc. So in this case we will have to write 1 by L equivalent is equal to 1 by L equivalent 1 plus 1 by L equivalent 2 plus 1 by L equivalent 3. Why we are writing this way means because this L means we have to include the mutual inductance also. So first let us find 1 by L equivalent 1, which is equal to, you can see we have to consider the first branch, that is 50 Henry inductance. So we are considering 50 Henry, so it will write 1 by 50. Now we have to consider the mutual inductance of this inductor which is linking with the other two inductors. So you can see we can consider this branch and this branch. So these two branches are in parallel. I can see that the mutual inductance between them is 10 Henry. Now how we will consider the sign, which is whether it is positive or negative, is based on this symbol that is given over here, the dot symbol. So this represents the current which is entering or leaving. Okay, so if you can see in the first branch the current is over here, we can consider this as the current is entering this branch, and in the second branch you can see the dot position is over here, dot convention is here, so this we can consider as the current is leaving. So here in one branch the current is entering and in the other branch the current is leaving. So if we have two different signs, that is one current is entering and in other current is leaving, so we will consider the sign as negative. If we have the same convention, that is if we are considering these both branches, these both branches current is leaving, so then we will consider the sign as positive. Okay, so if I have both leaving or both entering, current entering, then we will, in that case we will consider the sign as positive. So in this case, if you consider these two branches, one is entering and other is leaving, so here we will consider negative sign, minus 10. Okay, now we have to consider the next two, this branch and the third branch. You can see the mutual inductance between the first branch and the third branch is given as 20 Henry. Then how to find the sign? Here in this branch the current is entering and here in this branch the current is leaving, so we will consider the sign negative. So we will consider negative, so it is minus 20. Okay, so solving this you will get it as 1 by 20. Okay, so we got 1 by L2, so 1 by L equivalent 1. So next we have to find 1 by L equivalent 2. Similarly, we will consider, so we have to consider this branch, so it has an inductance 20 Henry. So we write 20. Then we have to consider the mutual inductance of this branch and the first branch. So the mutual inductance between them is 10 Henry, and how to consider the sign? Here the current is entering and here the current is leaving. So we'll consider a negative sign. So it is minus 10 Henry. Then next we have to consider the second branch and the third branch. So when we are considering the second branch and the third branch, you can see that mutual inductance between them is 12 Henry, and here the current is leaving and here also the current is leaving. So we will consider a positive sign. You have to remember, when both the currents are entering or both the currents are leaving, then we will consider the positive sign. So in this case, this
both case, these two inductors case, we will consider the sign as positive. So the mutual inductance we will write as plus 12. Okay, so you have to solve this.
So here you will get 1 by 22. Okay, now we got 1 by L equivalent 2.
Next we have to find 1 by L equivalent 3. Okay, which is equal to 1 by, you can check, this is a third inductor, it is given having in inductance of 60 Henry. So we will write 1 by 60. Now we have to consider the mutual inductance. So the third branch and the first branch we are considering. So here the current is entering and here the current is leaving. So we will consider a negative sign and the mutual inductance between them is 20 Henry. So you will write minus 20 Henry. Now again you have to consider the third branch and the second branch. You can see that when we are considering third branch and second branch, the mutual inductance between them is 12 Henry and here both the currents are leaving. So we will take a positive sign. So here it is plus 12, and if you are solving this, you will get 1 by 52. So now we have to add all these inductance. We are doing the summing. That is 1 by L equivalent is equal to 1 by L equivalent 1, that is 1 by 20 plus 1 by 22 plus 1 by 52. So you have to take the LCM and solve this.
So solving this, you will get the answer will be 0.11468. Okay, so the 1 by, we got 1 by L equivalent is equal to 0.11468. What we want is L equivalent. So L equivalent is equal to 1 by 0.1146, which is equal to, so we will get L equivalent as 8.7195 Henry. Okay, that is our answer.